Welcome back to Max with RP. Today we are going to solve some case studies in Maxima Minima. As you know, case studies are an important part of the assessment where you learn to apply the mathematical concepts to solve real life problems. Let us see such problems. So, in an elliptical, read the following passage and answer the question given below. In an elliptical field, the authority events to design a rectangular soccer field with a maximum possible area. The sport field is given by the graph of x square plus by a square plus y square by b square equal to 1. If the length and breadth of the rectangular field be Tx and Ty, find the area function in terms of x. Find the critical point of the function. Then use derivative test to find the length of 2x and 2y that maximizes area. Then use the second derivative test to find the maximum area. So what you have is an elliptical sport field in which you are having a rectangular soccer field. Okay, you have an elliptical sports field inside which there is a rectangular soccer field and we want to construct it with maximum possible area. So what is the equation of the elliptical field? X square by a square plus y square by b square equal to 1. Now, for the rectangular field that you have here, what are the dimensions? 2x and 2y. You have to find the area function in terms of x. So, area function, which I will call it as A, is equal to what? Length into breadth. So, 2x into 2y, which is equal to 4xy. Now, you want to express it in terms of x. The rectangular field is inside the elliptical field. Okay. Now, therefore, every point on the rectangle satisfies the equation of the ellipse. So, from this, you get y square by b square is equal to 1 minus x square by a square, which is a square minus x square by a square. So, y square is equal to b square by a square into a square minus x square. So, y equal to plus or minus b by a root of a square minus x square. So, the area function in terms of x will be, a will be 4xy, but y is b by a. Since area is positive, I am looking only at the positive square root, a square minus x square. So, this is the area function in terms of x. So, if length and breadth of the rectangular field are 2x and 2y, then the area function in terms of x will be 4x b by a into root of a square minus x square. Now, we want to find the maximum value of the area. First finding the critical point using first derivative test, afterwards using the second derivative test. So now, this is 4x b by a into root of a square minus x square. For convenience of differentiating, I am going to write a square as 16 b square by a square x square into a square minus x square. Now this area function a square, I will call it as say k, which is equal to 16 b square by a square is a constant into a square x square minus x power 4. dk by dx, this is a function of a single variable, namely x. So dk by dx will be 16b square by a square into a square 2x minus 4x cube, equated to 0. This implies 2x a square equal to 4x cube. X gets cancelled, giving you a square equal to 1x gets cancelled, so 2x square. Therefore, x square equal to a square by 2, or x is equal to a by root 2. This is the critical point. X is equal to a by root 2. Now, you have to use the first derivative test. How do you use the first derivative test? Take the number line, divide it via the point a by root 2. A is a constant. So, now what is the first derivative? This is the first derivative. This is the first derivative. Okay. Now, what will be the sign of the first derivative? Okay. You can ignore this and you can just, because this is always positive. So, I can substitute only here. What is that? 2x a square minus 4x cube. Okay. Now, what will be the sign of that when I put here to the left by a by root 2, I can put 0. When I put x equal to 0, what will I get? This is, instead of, 0 will make it 0, so it is inconclusive. So, take some other value for x. So, which is lesser than a by root 2. Okay. So, can I take minus a? Let me take x equal to minus a. Then what will happen? This will become minus 2a cube minus plus 4a cube. Why minus 4 into minus a cube? Which will be again minus a, minus into minus will make it positive. Now 4a cube minus 2a cube will be 2a cube, which is positive. Now beyond a by root 2, I can substitute a. So this is f dash of minus a. What will be f dash of a? F dash of a will be equal to, what is f dash of a? This is my second derivative. What is my second derivative? 2x a square minus 4x cube. In that, it's not second derivative, first derivative. In that, I have to substitute x equal to a. Then what will I get? 2a cube minus, when I put x equal to a, 4a cube, which is less than 0, minus 2a cube, which is less than 0. So, the function has a local maximum at a by root 2. Are you able to follow? So, the function has got a local maximum at a by root 2. So, use first derivative test to find the length of 2x and 2y. So, now what is it? X is a by root 2. So, what will be 2x? 2x will be 2 into a by root 2, which is root 2a. What will be 2y? I have to find 2x and 2y. What will be 2y? 2y will be, y is this? b by a. So 2 times b by a root of a square minus x square. A square minus x square will be a by 2. X square will be a square by 2. So this is what? 2b by a, okay, into root of a square minus a square minus a square by 2 is a square by 2. So if I take root, I will get a by root 2. So you will get root 2b. So 2x is root 2a and 2y is root 2b. Are you able to follow? So those are the values of 2x and 2y in terms of a and b that maximizes the area. Now, what will be the sign of the second derivative? Now, use second derivative test to find 2x and 2y in terms of a and b. Okay. So, now, how to find the second derivative? What will be the second? This is the first derivative. So, second derivative will be d square k by dA square will be, if I differentiate once again, 16b square by a square is a constant, 2a square minus 12x square. 3 into 4, 12, x square, 2a square. Now in this, I have to put x is a by root 2. So you will get 16b square by a square, 2a square minus 12, x square is a square by 2. So 2 square minus 6a square is minus 4a square, which is less than 0. So the second derivative is negative. Therefore, for x is equal to a by root 2, you have maximum area. When x equal to a by root 2, the size of the rectangular field, which is the length and breadth of the rectangular field, which is 2x and 2y, are given by 2x is 2 times a by root 2, which is root 2a. 2y is 2 times b by a into root of a square minus x square. X square is a square by 2. This is root of a square by 2, which is a by root 2. So you will get root 2 times b. So 2x is root 2a, 2y is root 2b in order for the area to be maximum. Is it clear? Let's look at the next problem, next case study. You have an architect who designs a building for a multinational company. The floor consists of a rectangular region with semicircular ends having a perimeter of 200 meters. So based on this information, you have to answer the following questions. First one, if xy represents the length and breadth of the rectangular region and a represents the area of the rectangular region, you have to find the maximum value of a. So you have to find the maximum value of a when a represents the area of the rectangular region alone. Now what is the rectangular region? Area of rectangle, you know it is length into breadth. So x into y. But we have to write it in the form of a single variable. How do we do that? We know that perimeter is 200 meters. What is perimeter? X plus x is 2x plus, this is 2 semicircle adds to one circle. So which is 2 pi r. R is what? Y by 2. Now this is equal to 200. Now this means x plus 2x plus pi y equal to 200. From here, you can write x in terms of y and y in terms of x. Okay. Now, what will be y? Pi y will be 200 minus 2x. Or y will be 200 minus 2x by pi. So, what will be the area now? Area will be x into 200 by pi minus 2x by pi, which is 1 by pi I can take out. I will get 200x minus 2x square. dA by dx, it's a function of x, equated to 0 will give you 200 minus 4x equal to 0. Therefore, x is 100, 200 by 4, which is 100 by 2, which is 50 meters. So, x is 50 meters. When x is 50, what is y? Y will be 200 minus 2 into 50 is 100 by pi. So, x is 50 meters, y is 100 by pi meters. So, these are the values of x and y, and when you have the critical point at x equal to 50. But will it give maximum area? How will you check? Let us check the second derivative. D square a by dx square will be equal to, when I differentiate this, what will I get? 200, when I differentiate, I will get 0, minus 4, which is less than 0. So, a is maximum at x equal to 50. 200 minus 4x is the first derivative. So, the second derivative will be minus 4. The derivative of 200 is 0. Now, the CEO of the multinational company, next part of the question, is interested in maximizing the area of the whole floor, which includes the semicircular ends also. So, let me use a different color for that. In that case, what will be the area? Area will be first the rectangular region, which is xy, plus area of the one semicircular region is pi into pi r square. Pi r square will be pi y square by 4. Area of a circle is pi r square. Since we have two half circles, it will be one circle, which is pi y square by 4. Pi r square, pi into y square by 4. Now this is, I'll substitute for x. What is x from here? 200 minus x will be easier to substitute for x. So 200 minus pi y by 2 into y plus pi y square by 4. This will be 100 y minus pi y square by 2 plus pi y square by 4. This is 100 y. I can write this as minus 2 pi y square by 4. So, minus 2 pi y square plus pi y square will be minus pi y square by 4. Now, dA by dy will give you, equal to 0 will imply 100 minus 2 pi y by 4 equal to 0. So, this is pi y by 2. So, pi y by 2 equal to 100. Pi y by 2 equal to 100. So, y equal to 200 by pi. When y is 200 by pi, what is x? When x is, what will be? Where is x? This is my x. So, when I get, substitute for x, I will get x is equal to 200 minus 200 into, because pi into pi will get cancelled, giving you 0. So, when y is 200 by pi, very important, x is 0. Where am I substituting for x? This is my x. So, x is 0. So, what will be the value of x when the area is maximum is when x equal to 0. So, when x equal to 0, what will be the area? The area will be a equal to pi y square by 4, which is pi by 4 into, what is y square? 200 square, 200 by pi, the whole square, which is 200 into 200 by 4 pi. 1000 by pi. square units will be the area. Are you all able to follow? Have you understood the two case studies? So, please work out by yourself and check whether this is what is the answer that you are getting. So, we could try two case studies today. I hope you found the session very useful and use this idea to solve more problems. So, until we meet next time, it's goodbye.